Hello everybody, hope you're doing well and thanks for joining us for another video. Well, Artemis 2's mission may have ended, but the fallout from it is still going strong. There's been so much false information and attempts to try and argue it was fake, there's probably more videos I could make about it. But the conspiracies related to Artemis began before they'd even reached space. There were claims of fakery being made just from the launch itself. Firstly, because quite a lot of people noted that as Artemis left the pad, there were carts leaving the top of the tower, and many were claiming that this was the crew sneaking away from the pad and not actually going to space. Not least, this was being claimed by one of the most well-known flat earthers, Eric Dubé.
Is the following footage showing these cable cars lowering from the rockets during launch. These are known as the emergency escape cable cars, allegedly used to get the astronauts out in the case of an emergency. They sure look like they're being used here at this last moment. How do we know that they're empty? The astronauts could easily have just hopped into those cable cars to be taken to the next studio where they sit in harnesses pretending to be in outer space.
Now, as Eric points out, these carts are for emergencies. It's the emergency egress system. The Artemis rocket is 98 meters or 322 feet tall, and it carries almost 1 million kilograms of liquid hydrogen and oxygen in the main tank. Well, that is a recipe for a very large explosion if it goes wrong. An explosion certainly large enough to destroy the entire launch pad. So, if NASA were to detect a problem and they needed the crew and the ground staff to get away from the rocket quickly, slowly descending the 100 meters to the base of the rocket and then trying to get away from it isn't really the quickest option. So instead, they have the emergency egress system, which within a few seconds can carry those people from the top of the rocket to several hundred meters away. Or, for the astronauts, if they're on board, they also have the launch escape system, which is the small tower section at the very top of the rocket, which contains rocket motors and is attached to just the crew compartment. Were there to be an emergency abort, this tower section would ignite and pull the crew compartment well clear of the rest of the rocket, a bit like an ejection seat on a fighter jet. But firstly, these emergency systems are not new to Artemis. Since the very beginning of manned rocket flight, there was attention paid on how to get people to safety in an emergency. Apollo and the space shuttle had the same sort of escape zip lines. They called them slide wire. Here you can see the shuttle crew during training on how to use the system, and here are some photos of Apollo 8's crew testing an individual zipline system. Apollo even had an emergency slide system where the crew and the ground staff could go into an underground shelter well below the launch pad. However, you'll notice that during those launches, the zipline systems don't move. So, firstly, if the crew of Artemis were leaving via the ziplines rather than launching in the rocket, then surely the lack of ziplines for Apollo and the space shuttle means their crews were still in those. Or if they also had methods of getting the crews out of the rocket and away from the launch pad without anybody seeing them, why didn't they just use the same mechanism with Artemis? Secondly, why throw the crew down the zipline at the last minute? By the time of launch, the ground staff were long gone and well clear of the rocket. You can see on the live stream, they closed the inner Orion hatch about 2 hours before the launch. There's still more than an hour left when they close the outer hatch, and at around 50 minutes before launch, the tower arm moves back away from the rocket. So if the crew weren't in the rocket at launch, they must have been out of it by this point already. Now, let's just ignore the crowds of people and the cameras that were watching from a distance, some even with telescopes like Red Rhetoric, who were able to see the crew head to the rocket, but not come back. The ground crew, after this point, headed down the tower elevators into vehicles and drove away to a safe distance well before launch. Why then would the crew not just go along with them? Seemingly, according to this conspiracy, having snuck out of the rocket with an hour to go before launch and walked back into the main tower without anybody seeing them, they've then stood around on the tower for an hour until the moment the rocket's about to launch, and then they've jumped into these baskets and gone down the zip line. That alone makes no sense, but then there's a far more fundamental way we can tell the crew aren't in those baskets, because if they were, they probably wouldn't be alive right now. Just from the cameras placed near the rocket at launch, you can tell the rocket is loud at liftoff. Now, I've not been fortunate enough yet to see a rocket launch in person, a downside of living on this side of the Atlantic, but the people who have been and shot videos of it, you can hear it's loud even from a few miles away. So imagine the noise to anybody still near the tower. It's stated that the noise level that the Artemis rocket produces is 176 decibels. For context, a flashbang grenade produces roughly the same level of noise, and the noise only lasts a fraction of a second. Bang out! That amount of noise for a prolonged period of time, such as several seconds as a rocket lifts off, would permanently deafen anybody next to it. Then you've also got the massive shock waves and the red-hot exhaust plumes that are being created by the rocket engines, which pass very close to the zipline baskets. In fact, from this aerial view of the launch, you can see just how close those exhaust plumes are to the baskets. Now, anybody inside them might not get a direct hit from the exhaust, but I suspect the air temperature surrounding them would get noticeably higher as the rocket lifted past them, and even if not, the shockwaves alone would likely cause serious injuries at best, given that there wouldn't be much protection from a thin sheet of metal that is full of holes. So why were the baskets released at all, and why do it right at the point of launch? As you can see from this footage, the baskets are exposed on the side of the launch tower and very close to the rocket itself. As the rocket lifts off, that region of the tower gets blasted by the exhaust from the rocket engines. So the baskets were sent down before this point, basically to protect them from being damaged, because then they wouldn't need to fix or replace them. In fact, during the post-launch press conference immediately afterwards, Sawyer Rosenstein from NSF asked NASA specifically about the baskets being released.
Thank you, Sawyer Rosenstein, NSF. I noticed that the slide wire baskets happened to deploy during launch. Was that something that was expected? And can you give any initial reports, at least what you've seen from the cameras, of how the mobile launcher is doing, given the hope to be able to quickly turn it around?
Yeah,
Do you have something on the baskets? I can talk about the turnaround.
The baskets are, they're supposed to get out of the way. That's part of the plan. So otherwise they take plume loads, and we don't like that.
So I can tell you...
But why wait until the rocket is lifting off? Given that the ground staff were well clear of the tower already, well, I am somewhat speculating here, but an educated deduction would be they wanted to wait until it was confirmed that it was actually going to launch. By that I mean the launch process goes through several steps. As liftoff approaches, the main engines on the core stage begin to start up. You see the sparks flying around below them, which, side note for anyone interested, the sparks aren't part of the ignition of the engines themselves. The engines run on liquid hydrogen and liquid oxygen, and part of the startup process pumps hydrogen into the engines. However, you don't want an excessive buildup of hydrogen around the rocket, because when the engines then do ignite, it'll set fire to all the hydrogen. You can actually see this with the launches of the Delta IV Heavy. They would release hydrogen for a few seconds before ignition, so when the engines then ignited, it also ignited all the hydrogen. The sparks are there to burn off any hydrogen as it comes out of the engine rather than allow it to build up. They had the same thing with the space shuttle launches. So, the sparks fly, and then the 4 RS-25 engines of the core stage ignite. These ignite a few seconds before the rocket lifts off, to allow time for the thrust to build up and to ensure that the engines are all working as expected. and those RS-25 engines can be shut down. So if there were to be a problem with them after ignition, they can be stopped and the launch scrubbed. However, a few seconds after the RS-25s ignite is when the SRBs ignite, and these solid rocket boosters can't be switched off. Once they're ignited, they keep going until they have no fuel left to burn. So once they're lit, the rocket's launching. And you can see that the baskets don't begin to move until just after the SRBs ignite. So I suspect they keep the baskets there in case the launch gets scrubbed before the SRBs are ignited. Once they're lit, it's guaranteed the baskets aren't going to be needed. But had they released it well before the launch and then a problem arise that forced an evacuation of the crew, NASA could have been left with the potential choice between a slow, riskier evacuation down the tower or using the rockets abort, which would then force a delay of at least several weeks or likely months because the rocket would need to be rolled back to the vehicle assembly building and rebuilt. So yes, the emergency baskets were released at launch, but the idea that there was anybody inside them as part of some elaborate hoax is both illogical and impractical, since they had ample time to leave the pad before the launch, and leaving it that late would seriously injure or even kill them. Though it's arguably not the most illogical and impractical conspiracy idea that I've seen about it, I think that particular accolade goes to Flat Earth Dave, who was on a live stream with fellow Flat Earther Mark Sargent, with the two of them doing a live reaction to the launch as it happened. And during the build-up, very early into their stream, Dave came out with this.
Momentarily.
Here, let me see what happens.
So let's talk about this. Those towers,
Yeah.
I saw somebody did a thing where there's a technology where they can have 3 towers that can project a real-life looking hologram.
Sure.
Minus 10 minutes and counting.
The 3 towers that Dave is referring to are these tall towers located around Launch Pad 39B, and he's suggesting that they're projecting a hologram of the rocket. These are in fact lightning towers. After all, we're talking about huge metal rockets filled with highly combustible liquid. You don't want one of them getting hit by lightning. Or, even if it's empty, a lightning strike could cause havoc with the internal computers, as was seen on Apollo 12 when it was struck by lightning 30 seconds after launch.
Move 100 feet. The hell was that? I lost a whole bunch of stuff. I don't know. Mark 1 Bravo. Roger, we had a whole bunch of buses drop off. There's nothing. It's nothing. I think it's... What we got? I can't see. There's nothing wrong. AC bus 1 light. All the fuel cells. I just got the platform.
And the rockets also sit on the pad for long periods of time between them rolling out of the vehicle assembly building and them actually launching. So for Apollo and the Space Shuttle program, the launch tower themselves had a lightning rod at the top of them to try and prevent lightning from hitting the rockets directly. However, these only really offered protection in a cone above the lightning rod. There was still a potential risk of the rockets receiving a direct strike. So NASA switched from lightning rods on the towers to these 3 lightning towers surrounding the pad in order to give full protection coverage from strikes. You'll notice that the Artemis launch tower doesn't have a lightning rod on it. Now, the lightning towers were installed sometime between 2006 and 2009 when NASA did some work on Pad 39B. I believe in preparation for the Constellation program. The Space Shuttle frequently launched from Pad 39A. The last launch from 39B was STS-116 in 2006. Here is a photo of that shuttle during its rollout, and there's no lightning towers at the pad. Then following the Columbia disaster, the shuttle Endeavour was placed on Pad 39B as a support for STS-125 in May 2009 in case there was an emergency. However, Endeavour ultimately didn't need to be launched, but here is a picture of it on the pad and the towers are now in place. In fact, here's a photo taken during the wet dress rehearsal for Artemis 1 back in 2022, showing the lightning towers doing exactly what they're supposed to. But even if we entertain the idea that they're projecting a hologram onto the pad is one thing. But there were crowds of people watching that thing launch with their own eyes. Did the towers project it all the way up into the air and out over the ocean? But then Dave manages to then contradict his whole idea by bringing up this last conspiracy, which is that rockets are launched into the ocean.
Yeah, the side rockets have dropped. By the way, where's our side rocket footage? You remember that from back in the day?
And now
Holy
look,
smokes, there we go.
side rockets don't turn off. How come they're not like spinning out of control?
Copy all, Stan.
You know what? It's going to go out. It's going to crash in the Bermuda Triangle. And if anyone says, "Oh, I saw it crashed," I just go, "Oh no, that was the side rockets."
Sure.
This, for me, highlights Dave's desperation to just give any explanation of fakery to his audience without actually thinking it through. First, he mentions the idea of the rocket being a hologram, but then flips to it being a real rocket that's launched into the Bermuda Triangle. But Dave is not the only person making this claim that the rockets are actually launched into the ocean. Eric Dubé also makes the claim.
Rather than shooting straight upwards towards the moon, which would be far more logical and look much more convincing, every rocket launch arcs from vertical to horizontal, and most you can even see beginning to arc back down to Earth before leaving view. NASA's excuse for this is that they are purposely doing this parabolic arc because of a super high-tech gamer gravity hack where the rockets are being caught in a gravity well that works like a slingshot to help propel them better to the moon. Yes, you heard right. The reason all these NASA rockets form a parabolic arc and look like they're about to drop into the ocean a few miles away is because going down is the best way to go up.
And I've even seen people posting memes about this on social media as well, claiming the rockets aren't going to the moon because they don't launch towards the moon. Firstly, the idea of launching a rocket whilst it is aimed straight at the moon fails to account for the fact that the moon moves. It takes a few days for a spacecraft to reach lunar distance, during which time the moon is orbiting the Earth. So if they leave Earth whilst aiming for where the moon is at that moment in time, by the time they get to the lunar distance, the moon will have moved thousands of miles. Instead, they need to aim for where the moon is going to be when they arrive. Just like how if you're trying to shoot a moving target, you don't aim for where the target is, because otherwise the target will have moved by the time the bullet gets to that distance. Instead, you have to lead the target. Now, as for why they launch into orbit rather than shoot straight for the moon, there's a few factors at play here. Firstly, the Earth's rotating, and the conservation of momentum means that any tangential speed being imparted on the rocket before it leaves the ground will still be there as it launches. That's why rockets launch to the east rather than to the west, to take advantage of that initial velocity from Earth's rotation rather than trying to fight against it. So, to fly straight for the moon, they'd either need to steer into the drift to cancel it out, or include the drift into their aim. Also, aiming straight for the moon heavily restricts when it is possible to launch, because if you miss the first window due to bad weather or a technical issue, you might not get another opportunity for days or weeks. Whereas going into orbit first not only gives the crew and the ground control the opportunity to make sure that everything is still working after the launch before they commit to flying to the moon, but they're in a parking orbit going around the Earth roughly once every 90 minutes. So if there were to be an issue, they would have plenty of time to troubleshoot it and then head for the moon on a future orbit. Then there's also the factor of fuel. Now, you might instinctively think shooting straight for the moon would require less fuel than going into orbit first and then doing a burn for the moon. But actually the opposite is true due to something called the Oberth effect. You need kinetic energy to reach the moon, and kinetic energy is half mass times velocity squared. So conducting a burn at higher speed gives you a bigger increase in speed than doing the same duration burn at a lower speed. And if you're aiming straight for the moon, you'd be thrusting directly away from the Earth. So you'd constantly be fighting against gravity. Meaning, as you burn fuel, some of the energy created by the burning of that fuel is immediately lost to gravity. But by pitching over and heading into an orbit, more of that thrust is converted into actual velocity rather than lost to gravity. And the same when doing the TLI burn. You're thrusting perpendicular to gravity rather than completely against it. And then, tying back to the Oberth effect, in an elliptical orbit, you're accelerating as you approach Earth. So at your closest distance is when you're traveling fastest, and thus any burn will then be more efficient. Launching a rocket straight at the moon would require more fuel. That extra fuel then needs more thrust to lift, and it basically just becomes impractical to do. But of course, that won't sway flat earthers, saying, oh, but you can see the rocket curving into the ground. Which you can't. What you're seeing is perspective. You can watch a plane fly overhead and then fly off into the distance. It will appear to drop down towards the horizon, but the plane's not actually descending. This becomes more evident, though, by the fact that not only were there people viewing the Artemis launch from the ground, but also from onboard planes. There was a tracking plane near the launch site which recorded the Artemis launch, and whilst the rocket does pitch over to begin heading into orbit, it does not start heading down. There were even passenger planes nearby, and people on board recorded it, watching Artemis not only not pitch down to land in the Bermuda Triangle, but continued way higher than the plane. And another proof that rockets don't just launch into the ocean off the coast of America is Starship. On the 7th test flight, they had a major malfunction and terminated the rocket over the Caribbean. It was seen by many residents of those islands, but it was nowhere near landing in the ocean at that point. It was still way up in the sky. Not only that, but then on Flight 9, things went more to plan, and it launched from Texas, crossed half the planet, and re-entered over Africa. And there's a channel called Astrolife that was streaming in Namibia during the event. And they had the live stream feed from SpaceX up on screen, as well as a tracker showing where it was in the sky. And then they literally turned their camera around to show the Starship trail as it re-entered the atmosphere. So there we are. Yet more conspiracies about Artemis that are really nothing more than a lack of understanding of orbital mechanics and an inherent desperation for the thing to be fake. But don't worry, there's still plenty more conspiracy claims about it that I haven't covered yet, but those are for another video. For now, as always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.